26enes jornades d'Eduard Fontserè. Ja sabeu que aquest any aquestes jornades estan dedicades a l'emergència climàtica en temps de pandèmia i en aquest sentit, doncs, si la primera ponència que vam tenir, la del doctor Pino, doncs ens parlava dels efectes de, en certa manera, quina influència va tenir o ha tingut la meteorologia sobre la Covid, doncs en aquesta sessió d'avui farem la visió inversa, és a dir, com la pandèmia ha influenciat en la meteorologia. I més concretament, sobretot, específicament sobre la previsió meteorològica i lligat al confinament de la primera onada. En aquest sentit, doncs, el doctor Chen serà qui ens faci aquesta sessió. Abans de tot, però, dir-vos que molts de vosaltres ja heu assistit a les altres sessions, però la mecànica és molt senzilla. El ponent tindrà uns 40 minuts, 35-40 minuts per exposar la seva presentació i posteriorment hi haurà un debat que es pot fer a través del xat, que teniu habilitat, i també, si volguéssiu, també podeu utilitzar els vostres micros. La sessió serà en anglès i si vosaltres us atreviu a fer qüestions en anglès, molt millor. Si no, doncs ja les traduiré jo i els hi faré arribar al doctor Chen. Bé, una breu introducció al nostre ponent. El doctor Chen es va graduar el 2006 en Ciències Atmosfèriques per la Universitat de Nanjing, a la Xina, i el 2009 va obtenir el màster en Ciències Atmosfèriques per la Universitat de Beijing. El 2017 es va doctorar en Meteorologia a Leibniz, a l'Institute for Tropospheric Research, a Leipzig, a Alemanya, i actualment és investigador sènior associat al Lancaster Environment Center del Regne Unit. La seva investigació se centra en la influència de l'ésser humà en el clima, en l'ambient i els processos atmosfèrics. A part de la seva faceta com a investigador i acadèmic, doncs també va passar 4 anys, entre 2009 i 2013, treballant per la companyia d'energia elèctrica més gran de la Xina, la State Grid Corporation, on va aplicar la tecnologia de predicció numèrica del temps per permetre l'ús de l'energia eòlica i solar a gran escala. Els seus resultats d'investigació s'han aplicat a més del 60% de la capacitat d'energia eòlica i solar a la Xina. Per tant, és uns estudis ben aplicats. I, a més, té més d'una vintena d'articles publicats a revistes internacionals, ha participat en molts projectes internacionals. Per tant, és una persona que realment ens fa molt de goig que avui pugui ser amb nosaltres. L'introduiré en anglès. Dr. Chen, thank you. Thank you very much for having accepted to be today the speaker of this conference. You have accepted enthusiastically, so that's great. And we are convinced that your talk will be of great interest for the audience. And go ahead, the floor is yours, and that's all for me. Thank you.
Well, thank you very much, Mike, for introducing me to this nice conference. And also, good evening for everyone. So I know it will be very nice that if I get the opportunity to visit Barcelona, this lovely city, in person. However, due to pandemic this year, we all have to attend this conference virtually. And the topic I bring today is about the impact of COVID-19 pandemic on our meteorology works. So the story will start from what is the daily work as a meteorologist, and then I will talking about how this pandemic will have impact on our daily work, and then I will talk about how the impact will be propagated into the weather forecast, and at last, if we still have time left, then I would like to share some recent study like talking about the pandemic influence on climate change. So weather forecast is a key part of the meteorologist's daily work, and why forecast is important because it helps us to make precautions for the extreme weathers, make better schedule for agriculture, and also better use of clean energy and closely related to our daily life, and also help us reduce the industry causes. I believe you know much better than me about why it's so important, so I won't go too deep into it. And when we talk about the weather forecast of meteorologist, so I guess this possibly will be the first picture coming to public's mind, like a handsome boy or beautiful girl stand in front of a screen talking about high pressure, low pressure, cold air invasion, front system, and precipitation. Yeah, it looks like a very shiny work, but the reality looks like this. So not as shiny as public expected. There are two key parts for the daily work as a meteorologist: observation and prediction. So in order to get a good weather prediction, we need a good observation for the current meteorological conditions in the atmosphere. And we did a lot of hard work, built a lot of observatories, not only in residential air, but also in the remote areas. And this observatory had to make the observations continuously and also regularly. Then we collect all of this observation data. And in the past, we put this data on a map and draw the weather chart. And this can help us analyze the weather system and predict the development of weather system. Therefore, we can have a good prediction for the future. And nowadays, everything gets changed. So thanks to the modern technique, and now we've got numerical weather prediction models, and we build in the atmospheric equations into these models, and the equations can help us describe the dynamic process in the atmosphere, and we use supercomputer to help us solve these equations. Then integrated throughout the time, we can get a prediction for the future. But this model or integration is start from the current condition. So we need a good description for the current condition. We also call it initial condition in numeric models. And as long as we can get a good initial condition, then we can get good prediction. And the observation, it provides great value to help us improve this initial condition. Now we use a modern technique called data assimilation that can help model absorb these observations into the model and make good initial condition and improve our weather forecast. So this is how forecast model works, and how to get a good forecast. As I mentioned, we need two key points. One is a good initial condition, and another one is we need to really understand and how the air mass developed in the atmosphere. So this will be described by equations. It's very similar like this spot actually here. So in order to get this target, which means we get a good forecast, then we need good initial condition. We can imagine that if we get some small error in the initial condition, then after this movement in the air, we may get a big error at the end, and we will lose this target. And the same, we also need to really understand what is going on in the air. So like here, if we don't understand the Newton's law and we can't really predict the movement in the between, then we will also lose this target. So here are two key points that can help us improve the weather forecast. One is to improve our scientific understanding, or we can also call it improve the equations. This can help us improve the forecast, but this is relatively slow to improve the scientific understanding. However, over the past few decades, we really have a big improvement in our observation system. And with data assimilation technique, these observations can really help us improve the initial condition, and then we get better forecast. And here we go. So this picture comes from the World Meteorology Organization, WMO. And here show the global observing system. Nowadays, we have more than 10,000 surface-based stations. This can provide us continuous measurement of the surface level meteorological condition. And we also get over 1,000 weather balloon stations. This radio sounding measurement can provide us the high vertical resolution meteorological profiles and also collaborate with a lot of commercial airlines. We now get over 13,500 commercial aircraft that can provide us two key information. One is when this aircraft landing or taking off from the surface, it can also provide us high vertical resolution meteorological conditions. And also when the aircraft cruising in the air, it can provide a unique data set for the remote regions and also the meteorological condition in the upper airs. We also get a lot of ship observations that can provide us the conditions over remote ocean and also moored buoys and drifting buoys. And also thanks to the modern technique, nowadays we got more than 200 satellites. This satellite can continuously provide a very unique and also very valuable data set to help us improve the forecast. First thing is, it can provide the global coverage observations, and also these satellites need much less maintenance. So even during the pandemic, satellites still work as usual and can really help us keep the forecast skill during this pandemic. But satellites also have its own disadvantage. So one thing is this satellite is the remote sensing observations from the space. So it needs calibrations. Therefore, we still need this in situ, or we can also call it the conventional or traditional observations that can help us calibrate satellite observations. And the second thing is most of satellite products, it provides the observation of a column value, and it doesn't provide the vertical information. So we still need this aircraft and the balloon observations that can provide high vertical resolutions. Therefore, this conventional observation data set is still very valuable and irreplaceable. And the focus for today, we are going to talking about these commercial aircraft observations because it's one of the most valuable data set, and also it is largely impacted by this pandemic. Okay, in the next section, we are going to talking about how these observations will be impacted by pandemic. And here we go. So you can see that we have like hundreds of aircraft flying in the air. You can see from this animation. And for the busy regions like Europe, North America, and China, you can see a lot of airports, and they provide high resolution vertical information when an aircraft is landing or taking off, and also provide the high level meteorological condition when aircraft across the continent. And all of this information will be collected by this program. It's called Aircraft Meteorological Relay, organized by WMO. And then this information will be shared to forecasting centers. So this is what it used to be, but for 2020, due to the global lockdown, lot of aircraft now it's grounded on the surface. So the observation level is reduced in a very large level. And here it is. So we can see the aircraft observation, it kept climbing up over the past few decades, start from early 19th. And we can see, especially for recent years, we got a soaring climbing up, very fast increase of the observation numbers. And also we can see some signal here about start from 2008 and until 2010. In these 2 years, we see a small decline. This is related to the global economic crisis. And after this, the economics start to recover, so we can see a fast increase of it. But until early of this year, we see a cliff drop of this observation, and this brings us back to about 10 years ago. But don't worry, although aircraft is very valuable for forecast, and this will not bring our forecast back to 10 years ago, because our forecast model is keep improving during these 10 years, and also the improvement in other observations, such as more satellite observations. And which region is impacted in most? So here we can see a global view of the impact on aircraft observation. So this data comes from ICAO, International Civil Aviation Organization, and here you can see that for the international travels, so like Asia and the Pacific, it's the region that impact most. So it's reduced by over 70%. And also for the other two busy regions like Europe and North America, we also see a very large impact. The aircraft observation reduced by over 60%. So if we zoom in this window to just for this year, we can see more details. So you will find out that at the beginning of the year, like in February, it's still okay. So it still keeps the observations in a high level. So we can just focus on this black line over here. It's the total number of observations. And then we see start from March. So March, April, and May, we get this cliff drops of aircraft observation down to about 20 or 25%. And after this, we got a slow recovery at the end of the spring until summertime. Then after summertime, due to a second wave, so we get decrease again. And so we see this pandemic have a very big impact on observation. And now we are largely lacking this observation and how long this situation it could last. So based on the projection from this ICAO organization, so they project that this recovery will start from the summer of this year and very fast recover afterwards, and until the beginning of next year, we may back to normal. However, I think this projection, you can see this specialized, possibly is too optimistic, and due to the second wave coming, so we may have to stay in this condition for a much longer time. And so then we start to think about, well, aircraft observation is so important, and we may stay in this situation for a much longer time. How big impact it could have on weather forecast? It's a good question. So let's take a look here. Before we go into 2020, first I would like to introduce about how important it is for these aircraft observations for the weather forecast. So here is a previous study that they show. So let's start from the bottom here. So you can see satellite, it provides great value, really help us improve forecast. And it's the largest improvement among all data sets. However, this in situ and conventional observations, you can see from here that aircraft is on the top of the list. And this is for the dry total energy forecast for long-term statistic performance analysis. And also another study in 2016. So this is a statistical performance, long-term performance for wind speed forecast. You can see among all of the in situ observations or the conventional observations, aircraft is still on the top of the list. So this is all about long-term performance. We also think about, well, how important it is for the case study, for example, like extreme weather cases. And here also is another study, a previous study showed that aircraft is important for the hurricane case study in North America. So you can see for this hurricane forecast, this aircraft meteorology data relay data set is still on the top of the list. So it clearly shows that for both long-term statistic performance and for the extreme weather cases, aircraft is one of the most important data sets that help us improve the forecast. And this impact not only for the up there where aircraft is cruising in the air, that impact can also reach down to their surface level. And also, so this is a case study provided by ECMWF. So they performed a sensitivity study for last year, 2019. And in this study, they also used the data reject sensitivity study, which means compare the forecast with aircraft and without aircraft. So you can see here for wind speed forecast, the influence from surface up to about 200 millibar level, and the biggest influence is in the up layer that can increase the original air load by about 50%, but may show here the largest impact is in short-term forecast, the 12-hour forecast, and with forecasting time goes longer, the relative contribution to this air load is decreased. But keep in mind here, what they show here is the relative air load change, which means, well, it changed relative to the original air load. So think about that. Here it's like 5-day forecast air load. So the original air load could be much larger than the short-term forecast. Therefore, if we look into the absolute air load, that might still be considerable, and which I will show you later on in my study. And so we have already seen from the previous years that aircraft is one of the most important data set, and this is what it should be, and this is what exactly it is now. So due to this lack of observations, how big impact we can have for this year, 2020, and I'm going to show you here. So in 2020, obviously, we are not able to perform this sensitivity study, compare the forecast with aircraft and without aircraft, because we don't have this data in hand anymore for 2020. But what we can do is use a method called difference in difference. So here we can take the February as a reference for this year. And because February, we still have high level of aircraft observation available, and also using February as a reference, we know what kind of performance we can expect it for 2020. Then we analyze this time window when we get a cliff drop of the aircraft. So March, April, and May. Then we compare the performance in this March to May against the performance in February, and then we might able to estimate what kind of impact we will get for 2020. And here we go. It is. So let's start from February. Yeah. And here the color show you the performance. So blue color indicates 2020 we can expect the improvement in the forecast, and the red color show you that the forecast is going worse in 2020. And the y-axis here is the latitude that average over longitude. And the x-axis here show you the forecast time. So 1 day, 2 days, 3 days, until 1 week forecast. And here you can see a very clear signal that apart from the relative humidity, with surface temperature, surface pressure, and also surface wind speed, we all can see a lot of blue color here. So which means, well, we can reasonably expect that in 2020, forecast actually should be better compared to previous years. And this, I think we should thanks to the upgrade of forecasting model by the end of last year, and this did improve the forecast performance as we see the evidence for February. But what it is now, so you can see here, this is March, April, and May. So you can see clearly the signal changed or the color change. Let's do it again. So this is February when we still have lots of aircraft available, and this is March to May when we have well, about 25% aircraft available. So February, March to May, February, March to May, February, March to May. So you can see it clearly that all the blue signal is changed to red signal now. So which means we can expect an improvement in forecast. However, due to lack of aircraft observation, this improvement is not in place, and sometimes it even go worse. And we also see that this forecast performance degradation is developed worse when the forecast time goes longer, as you can see, for example, here. So for the short term, not very much impact, but for the long term, we see bigger impact. And here, what I analyzed is the absolute error. But if we calculate the relative error, that impact might be minor. And we also noticed that the biggest impact is in high latitude regions. So we will go into this point later. And also for 2020, in this analysis, we also see the impact not only for surface level, that impact reach up to about 200 millibar level. And if we talk about the global distribution of this impact, so here we can see on a global map, this is February and this is March to May. And the number here give you the surface-based observation stations within this region. And I will come back to this point later. So you can see clearly that lot of blue color or dark blue signals in February, which means we can reasonably expect better forecast for this year. But lot of blue color change to the red color here, and some region, the blue improvement is vanished here. And so in order to make a more clear signal, so we use this March to May minus February. So as we mentioned before, this method difference in difference. So here you can see a more clear signal. The blue color here indicates the degradation of forecast performance. So you can see for the busy air flight regions such as China and the coast region of North America, we see a lot of red signal here. This is because, well, one thing, it should have a lot of aircraft observation, but due to the pandemic or lockdown, now we don't have it. That's why the forecast performance decreased. And also, we see a big decrease in the remote regions, such as Greenland, Sahara Desert, and the Hibernia regions. So this, I think, it is because of in these remote regions, we have very limited surface-based observation stations, and therefore it very rely on the other observation data set that can help them to improve the forecast. And we can also see some evidence from here, the case of Europe. So something surprised me at the beginning it is, so we should expect a big impact over Europe because Europe has a lot of very busy aircraft airlines over here, and also very impacted by the lockdown. But we see some signal in the South Europe, but in most part of something like Western Europe, there's not very much signal here. And I think this can also thanks to this high density of surface observation in Europe. And because of this high density data set that already provide enough information to help us make better or good enough initial conditions. So that's why can somehow compensate the impact from this pandemic. Oh, sorry. Yeah. So from here, we might learn some lesson that. So if we could introduce more observations, especially in the data sparse regions, like these remote regions, this might have the biggest help for our forecast skill in future. Okay. And what about the precipitation? And here I analyze the precipitation. So although we can see some blue spot and the red spot here next to each other, but not consistent and very clear signal here. So I think possibly not significant impact on precipitation forecast. And I guess this could be due to the forecast of precipitation possibly is dominated by the improvement from the satellite observations, and the satellite, it's business as usual during the pandemic and provide great help for our rainfall forecast. Okay, everyone, I think about this extreme weather forecast. Although I didn't analyze it in my study, but thanks to ECMWF, they provide this chat for me. And this is not for 2020, but for the last year, 2019. So here they analyze the tropical cyclone track forecast, and they perform this sensitivity study. So red color is with aircraft, and the blue color is without aircraft. So you can see the arrow. So we can see without aircraft, we got slightly increase of this track forecast arrow, and this degradation of forecast performance. So you can see some signal over here. The performance or the impact of aircraft, it gets larger when the forecast time goes longer. Although this signal is not that significant, but still some signal is showing here. Well, okay. Then the last section is about what kind of impact we can expect it from this pandemic on climate change. So a lot of recent study already show that, well, during this lockdown, the anthropogenic emission of greenhouse gases and also air pollutant, it goes down largely. So we expected a reduce of global warming. The answer is not that simple, I would say. So because here you can see, although we got climate warming from the greenhouse gases and also climate cooling from the air pollutants, but during the aerosol pollutant, but during the lockdown, both of them are largely reduced. So may cancel out each other. And also here, we do see from the satellite studies, we do see a big decrease of air pollution reduction in China and also in India. And so how should we expect the change for global climate? And here is the answer. So from this picture provided by NASA, so we can see actually this year, 2020 May, is the warmest on the record, even without a needle. So why it's not bring us the slowdown of global warming, even enhance the global warming, this cut of emissions? And a recent study from Leeds University in UK, so they show that during the lockdown, this greenhouse gas warming effect is going down, but also the aerosol cooling effect is going down even larger. And if in total, this is the blue color line here, you see the net effect is an enhance of global warming in short term, although we can expect a long-term decrease of global warming. And another study showed that if we can go through this pandemic very fast, then we get some minor increase of surface temperature. But if we stay longer time to go through this pandemic and more lockdown because of this reduction of emissions, so we can have large increase of surface temperature over the continent and some surface temperature cooling in the Arctic regions. So this might increase the temperature gradients from mid-latitude and high latitude. And this may introduce more of frequency of extreme weathers. Well, the last thing, but I think it's the most important thing, is we already see a lot of a very big impact from this pandemic. And I think we can take this pandemic as a lateral experiment that help us test what can we expect it from on these emission restrictions. And so what kind of lesson can we learn from this pandemic? I think is the most important thing. And here's some thoughts from me. So from the meteorology side, we see observation make great help for our forecast and introduce more observations, especially into the data sparse regions. It make great help for future forecast. And so this might tell us how can we make the best investment for observation. And also satellite is a unique and great value for the weather forecast. Also, or if we could introduce some new technique like change the manual observation station into automatic observations that can help the observation and the forecast be more robust, and especially during this global emergency like global pandemic. And diverse observation is better. And for the climate point of view, so I think when we're talking about global climate change, we have to take this aerosol and the greenhouse gas both into consideration. And also in the future, if we shut down anthropogenic emissions very fast, then we may need to be prepared and make a precaution for a short-term warming effect, and also be prepared for more local extreme weathers. So I would like to encourage you for more discussion about this. What can we learn from this? I think this is very important, and your work is also important, and your thought really matters. So at the end, I would like to thank my collaborators from EMWF, UK Met Office, NOAA, and the Australian Bureau of Meteorology. Well, that's my talk, and thank you very much for your attention. Happy to take questions.
Yeah. Thank you very much, Ying, for this wonderful presentation. It was very pedagogic, and I think there will be a lot of questions, I think. If not, I have one, but I'll wait. I'll wait. So, ara si voleu fer preguntes, veig que hi ha algunes que estan... Questions are coming. Well, if you want, I'll make one to you.
Yeah, please.
Yeah, just to make some time. It was thought that the aircraft observations will substitute observations from weather balloons. Do you think that from this pandemic we have learned that this information is also needed?
You mean the weather balloon?
Yeah.
Yeah, definitely. Actually, I think in Europe during this pandemic, so people thinking about how to do something and to make some compensation of this lacking aircraft. So we do introduce more balloon observation in Europe, and also possibly, as you can see from my presentation, that Europe compared to the other regions, it's very minor impact. So I guess, well, we also have to make some credit to this additional balloon observation over Europe. I think it do help, and this, well, we can call it also like a lateral experiment. This lateral experiment also demonstrates that balloon observation provide good value for the forecast.
Yeah, good. Thanks.
Thank you.
Well, there are some questions from Albert. I think it's quite close to that. Do you know if the WMO has considered to increase the number of sounding balloons, maybe in regions that are without weather stations or information?
Well, very good point. Yeah, I believe in the long term, we are planned to increase the number of sounding balloon observations regularly, and also, well, of course, we will keep do our best to increase, but the question is, well, depend on the financial. We know that bloom observation, it costs a lot. So this equipment on the bloom, it's just one-time use, then we lost it. So that's why at the end of my slide, I also think the development of new technique can be important. So if we can develop like some low-cost sensor can replace some relatively expensive sensors on the bloom and reduce the cost, this will have a very big help for the future to extend the bloom observation.
Mm-hmm. Thanks. There is another one from Mireia. Could you comment more on the long-term temperature decrease as a consequence of CO2 decrease and aerosol concentration modification?
Yeah, I think, well, because aerosol we know it's like one of the central pollutants, especially in some megacities we heard about, or like Delhi and the Beijing pollution is all because of aerosol. So anyway, from the air quality point of view, we have to reduce this aerosol. But from climate point of view, aerosol it exerts some cooling effect that can partly cancel off the CO2 global warming. So in the long term, we have to reduce our anthropogenic emission to reduce this global warming but we're also thinking about how to improve the air quality. So this somehow conflict with each other, and so some like engineering method is considered something like marine cloud writing. This kind of geoengineering plan is considered try to minimize this short-term try to minimize the short-term global warming due to this reduction of air also. But I think the key point of this is due to the lifetime of CO2 and the aerosol, because CO2 have much longer lifetime, like decades in the atmosphere, but aerosol usually just take about a few weeks. So aerosol responds much faster than CO2 to the cut-off emissions. That's why we got different in short term and in long term.
Mm-hmm. Good. I think Geroni has a similar question. Is having into account the substantial reduction of traffic and industries due to the COVID, why do you think is the reason of no reduction of CO2 concentrations? Maybe I think you have already answered that.
Partly answer that, because CO2 have much longer lifetime, so it will take like decades lifetime in the atmosphere. So just reduction for a few months, the atmosphere will not respond that fast. We need some time for the biosphere that can fix the carbon from the atmosphere into the soil. Then we will reduce the CO2. I think this is the best plan for future.
Mm-hmm.
Thank you.
Thanks. Well, I don't know if there are more questions coming, or you can use your micro. Podeu utilitzar el micròfon i parlar directament. No questions. As you mentioned, Ying, it was a nice experiment.
Yeah.
To know what's the response of the weather and the models to this reduction of observations. So in that sense was a positive effect of the pandemic.
I think every cloud have a sliver edge. So like we have to see everything with both sides. Although this pandemic already happened, we can't change it, but we can do our best to try to learn some useful experience that can lead us to a better future. That I think is the most important thing for this pandemic.
Mm-hmm. You're right.
Thank you.
Bé, no sé si hi ha més qüestions o més preguntes. No veig que ningú estigui escrivint. En tot cas, doncs, bé, moltes gràcies. Thank you very much, Dr. Chen. It was a wonderful talk, and we hope that in the next future we can meet each other in Barcelona.
Yeah, I'm very looking forward to that.
Yeah.
Barcelona is a lovely city, and also with wonderful food.
There are some questions appearing. There is a question from Gerard that said that how the pandemic affected the heat island of urban environments. Do you have noticed something related to that?
Well, I believe there is some impact on urban island heating. Like we have much less city traffic that can reduce the heating emitted from the cars and the vehicles. But I haven't really looked into it. It would be very interesting to see some result of it. So if you have any result, I will be very interested to hear some updates from you, or if you like, I will be very happy also discuss with you.
Mm-hmm. Good. And another question from Gerard, he said that there is some relationship between the great amount of tropical cyclones and the COVID.
Well, I think this we haven't really looked into it, but I don't know if this pandemic reduce of emissions really affect the number of tropic cyclone or not. Well, it's hard to say because we don't know how it should be if emission as usual.
Mm-hmm. Yeah, it's hard to know.
Yeah, it's hard to say.
Yeah, to say the weight of this factor. Yeah.
Yeah.
Okay, I think that Jeroni is typing.
Yeah, hope some sensitivity modeling studies will give us the answer of it.
Yeah, I'm sure that more papers on the effects of the pandemic will appear in the next years. Sure.
Yeah, I believe so. Yeah, it's much longer than everyone expected. Yeah, so I think it's just for a few months, maybe not have that significant impact, but much longer than everyone expected. So, or maybe we will see some signal of it, but I don't know the answer yet.
Mm-hmm. And there is another question from Albert. He says, has it been any change in the global albedo due to the drastic reduction of air traffic and the high clouds they produce?
Well, this, I think we can see some signal from the satellite observations, but I didn't look into it. But I believe there might see reduction of the cloud due to this. Otherwise, we can't really explain why the temperature is going up in this year. I think the net is because of more solar radiation is coming into this system, and the reduction of the cloud possibly can be one reason of it.
Mm-hmm. Thanks. Okay, thank you from Albert.
Thank you.
And I don't know if there are some more questions coming. I think you have a lot of work to do on this topic, and I'm sure that
very good point. Was to dig deeper.
Yeah. Okay. So thank you again and for
Thank you
this
much.
presentation. And as mentioned it before, see you in Barcelona, hopefully.
Yeah, hopefully in near future.
Yeah, sure. I per l'audiència, moltes gràcies per haver assistit. Recordar-vos que dijous vinent tindrem la quarta sessió de les jornades a les 7, amb la presència de l'Eloi Badia, regidor d'Emergència Climàtica i Transició Ecològica de l'Ajuntament de Barcelona, que ens parlarà de l'estat d'emergència climàtica, reptes actuals i futurs. Res més, moltes gràcies de nou per la xerrada i ens veiem dijous. Gràcies, passeu bé.